So page 27, we're going to construct an exponential function. Construct an exponential function. So it says in the last lesson, we worked with exponential functions based as a percent of increase or decrease. That's typically how you're going to see them. Now we're going to learn how to create those equations given a couple of parameters. So exponential functions have been given to you guys in this form. This is how we're learning it, right? It's either f of x equals a times b to the power of x, or we use y. Remember that f of x and y mean the same thing. The two parameters are that a is the y-intercept. We know that. It's the beginning value. And b is the growth or decay factor. We also call that the multiplier. We know that b is our growth or decay factor. We call that the multiplier. This is page 27. Page 27. Does everyone see where we are? Does anyone need more time to get there? Okay. So economists are modeling the average price of a gallon of milk as a function of the number of years since 1970. So they come up with this following equation. So here's our equation right here.
Teachers, please excuse this interruption, but at this time, bus 259 has arrived on campus, so please allow these students to go to class. Bus 259, the late bus has arrived, so please allow these students to class at this time. Thank you.
So I want you to look at that function, that equation, and someone tell me what the initial value or what the price of a gallon of milk is. What's the initial value? Initial value. $1.37. That means in 1970, a gallon of milk was $1.37. God bless you. That's what that means. In 1970, a gallon of milk was $1.37. What does this mean? What is that 1.026? It's the growth. Okay, how much is it growing? So question B, it says, give interpretation of the two parameters. We know that A, we just said is 1.37. And that's the price in 1970. We know what the B rate is, but I want to know what the growth percentage is. What is the growth percentage? How am I going to find that? Yeah, I'm going to take the 1.026 and I'm going to subtract 1 from that. And when I do that, I find out that it's growing at a 0.026 decimal. I need to turn it into a percent. How do I do that? Yeah, you can multiply by 100. Or when you multiply by 100, you're actually moving the decimal how many times? 2. So it's growing at 2.6% annually. It's increasing by 2. The cost of a gallon of milk is increasing by $2, by 2.6% each year. So question A says, so now we've kind of explained our parameters. Question A says, let's use this function right here and predict how much a gallon of milk is going to cost in the year 2021. How am I going to do that? What do I need to do first to figure out how long that's been? So I'm going to subtract 2021 minus 1971 or 1970, and I get 51 years. And so what do I do with that 51? That's your exponent. Okay. So put that into your calculator. 1.37 parenthesis 1.026 to the power of 51. And let's figure out the cost in 2021. Put it in your calculator. Let's see what you get. 1.37 parenthesis 1.026 exponent 51. It's $5.07. The cost in 2001 is about $5.07. According to this model, right? According to this model, that's what the cost is going to be. Okay. Do any of you guys remember how much a gallon of milk cost in 2021? Probably around that. I don't think it was as much, but I might be wrong. So yeah, probably. I would say $4 something. So we want to be able to construct an exponential model if we have enough information. So in this course, we're going to limit the amount of information we need to either an initial value. We're going to know the initial value and one other input pair, or I will give you two output pairs. Two X, Y ordered pairs. Okay. So the first example says we have these two ordered pairs. We're going to use the ordered pair 0, 8 and the ordered pair 1, 12. So I'm going to set it up as a table first off and hope that you can see something that's happening. So when X is 0, Y is 8. And when X is 1, Y is 12. God bless you. So can you look at those ordered pairs and determine a parameter in the form Y equals A or B times power of X? You guys see that one of these ordered pairs represents anything, or can you determine that? What do we know? What happens when X equals 0? Okay, so when X equals 0, you get the what? Don't you get the y-intercept, which is your A value, right? So we know that A equals 8. Okay, we know that A equals 8. So that's at least something that we know. So let's use the fact that we know that A equals 8, and let's use this ordered pair. And remember that this ordered pair, the ordered pair 1, 12, 1 is the X value and 12 is the Y value. And we're going to plug it into our equation. So our equation is Y equals, we just said that A is what? 8 times B to the power of X. But we are replacing X with what? What is X in our ordered pair? 1. We're going to replace the X with a 1. And what are we replacing Y with? 12. Okay. So what is B to the first power? It's just B, right? B to the first power is just B. So can't I divide both sides by 8 and figure out what B is? So B equals 12 divided by 8. Can I reduce that? I can divide them both by what? Put it in your calculator. Put 12 divided by 8 in your calculator. What do you get as a fraction? What'd you get? 3 over 2. Yeah, it's 3 halves. 3 halves. That's your B value, okay? So what is our equation going to be? Y equals 8 times 3 over 2 to the power of X. You guys just came up with that from two ordered pairs. You just learned that from two ordered pairs. Okay. Question number 3 has us comparing growth factors. We're comparing growth factors. So you can look at this first equation and see that B, my growth factor, is what? What is the value of B? 2.25. Let's figure out what the value of B is here. So How can I do that? Well, I can take the larger output, 196, and divide it by the output that came right before it, 112, because we're just growing by 1 on the x-axis. So what is 96 divided by 112? 1.75. So which one has a larger growth factor? Yeah. Function number 1 is larger. This is the growth factor for function 1. This is the growth factor for function 2. 2.25 is larger than 1.75. Go ahead and flip your pages. Flip over. So sometimes we're going to have to take the roots of a function. Like if we get an output, if we get an x value of anything greater than 1, we're going to have to use the roots, meaning we might have to take the square root or the cube root of something. So when I look at this in exercise 4, we're just looking at how do I get x all by itself? How do I get x all by itself? Well, you can put it into your calculator. Think about this. This says x squared equals 196. If I want to get x all by itself, I'm trying to make that bigger. There we go. If I want to get x all by itself, how do I unsquare something? I take the square root of it. But whatever I do on one side, I see it's frozen. Whatever I do on one side, I have to do to the other side. Okay. So that means x equals, well, I want to tell you something. When you actually draw the radical symbol, that's what that sign is, right? It's a radical. When you actually draw that radical symbol, you have to remember that square roots have both a positive and a negative root. So what is the square root of 196? Yeah, it's positive or negative 14. Why is it both? Because a negative times a negative is a positive. Typically, we work with the positive root, which is called the principal root. So we usually just work with the principal root. And that's the positive one. But I did want to show you that when you draw that, you need to put the plus or minus. So what about when I cube something? When I cube something, and this is good for you guys to learn how to do on your calculator. So how do I uncube it? How do I uncube n cubed? Yeah, I have to take the cube root. We should probably shut that off, whose ever phone that is. I need to take the cube root. I need to take the cube root. So on your calculator, you have, let me turn mine on. In your math button, like if you guys press the math button, number 4, so when you press your math button, item number 4 says this, has this picture. And item number 5 looks like this. Okay, so if you want to find the cube root of 19.683, you can press number 4 and it'll pop up your cube root. You guys see that? And you can put 19.683 in there. So you can press number 4. It gives you this symbol and you type in 19.683. Or if you use this button, because sometimes you have a 4th root. So if you're going to use button number 5, it's because you have a root that's bigger than 3. You have to press the root that you want first. You have to press the root that you want first. Okay? So I would press 4, and then I would hit math and press number 5. So my 4 already populates. So I'm going to hit the number 4, so I'm looking for the 4th root, and then math, and choose number 5, and it already populates that I want the fourth root, and you can put in the number 152. Okay. It's good for you to be able to know how to do that on your calculator. Okay, so what did we get when we did the cube root? When you found the cube root of 19.683, what did you get? What does n equal? Did anyone do that? Yeah, n is 2.7. Okay. When I find the fourth root, of 152, I'm going to type in 4, and then I'm going to go to the math button. And I'm going to select number 5, and it's going to give me something that looks like this. I'm going to type in 152 and hit enters. So what is the fourth root of 152? So you divided by 4. Whoever said 36, you took 152 divided by 4. Yeah, I got 3.51. We've done it twice. 3.51. Did anybody else get that? Okay, good, good. So for this next one, we have a fifth root. So this one says I need the fifth root. So the first thing that you're going to do is you're going to press the number 5 on your keypad, the number pad. And then you're going to hit the button that says math. You're going to press that button and you're going to select number 5. And when you do that, it's going to populate something that looks like this. It's going to populate something like that. And I want you to put in 1.5. So it has the 5 out there for you. So 5, math, 5. And I'm going to put 1.5 in there and hit enter. And what do you get? It's about 1.084. It's about 1.04. I know it says round to the nearest hundredth, so that would be 1.08, but I want you guys to see that. So does everyone know how to find roots in their calculator? If you don't, you need to raise your hand. Okay. So exponential models with the initial value a and any other value that lies on the exponential function. So we're trying to move up. It's not letting me. So we're going to look at this one. So we're going to take the ordered pairs 0, 48. So I have the ordered pair 0, 48. And I have the ordered pair 3 and 4,374. Okay. Well, what do I get from the ordered pair 0, 48? What does that tell me? Okay. It's just like the example before. Say again. Yeah, this is the y-intercept. So this is the a value. A equals 48, right? That's what I get from that ordered pair. Remember that I cross the y-axis when x equals 0. So that's my y-intercept. So now I'm going to plug that into this function, and I'm going to change out my x with the number 3, and I'm going to change out my y with the 4,374. So I'm plugging that all into the parent function, right? So instead of writing the number or the letter y, what am I going to write? 4,374 equals, instead of writing a, what value am I inputting in there? 48, parenthesis, b, and instead of writing x, I'm using 3 to the power of 3. So we have to get the b value all by itself first. We have to get the b value all by itself first. So how am I going to do that? How do I get b cubed all by itself? Because right now it has a 48 in front of it. Right now it says 48 times b cubed. What's the undo of times? Divide. So I need to divide both sides by 48. I need to divide both sides by 48. So what do you get? It's going to be a decimal. Yeah, 91.125 equals b cubed. How do I uncube my b? I have to take the cube root of it. But whatever I do to one side, I have to do to the other side. So you're going to type in the math button. So just hit the math button and select number 4. Math button, select number 4. And it's going to populate that cube root for you. Do you guys see it? Yes, we see it. No, we don't. Okay. So math number 4, and it looks like this. And you're going to input 91.125. And when you do that, what do you find out that the value of b is? It's 4.5. So what is the equation that we're writing in example C? What is the actual equation that we're going to write in example C? Yeah, y equals 48 parenthesis 4.5. God bless you, to the power of x. Okay. What is the function's value when I input x as 2? Well, that just means take your function y equals 48 times 4.5 to the power of 2. Put that in your calculator. Tell me what you get for your output. What does y equal? Anybody? Go. Yeah, it's 972. 972. Last example. Engineers are draining a reservoir. So if we're going to drain something, are we going to show growth or decay? Decay. We're draining something, so it's going to be decay. So they're draining a reservoir that holds water, and they're tracking the depth of the water still left in the reservoir. Given the graph shown, they would like to model it using an exponential function. So we need to create a model based off of the graph. So we're going to use the 2 ordered pairs from the graph. And we're going to calculate a function like a y equals ax plus a times the power of, a times b to the power of x. So what does this ordered pair right here give me? Yeah, it tells me that a equals 38. What does this ordered pair down here give me? Well, I think it gives me an x and a y to plug into my function, right? So instead of using, I'm using this model, but instead of typing in or writing down the letter y, what am I going to put in? What is y from the ordered pair? 11 equals, what is a from the 38 times b to the power of, what is x? 5. Okay. So we have to figure out what b to the 5th power, like we have to undo that. But before we can do that, we have to get b to the 5th power isolated. So what can I divide both sides by so b is all by itself? Yeah, I'm going to divide both sides by 38. Okay. So give me that number as let's do 4 decimals. So what is 11 divided by 38? 0.2894 equals b to the 5th power. Okay, so we have to figure out what b is, right? We have to figure out what b is, so we need to take the 5th root of b to the 5th, which means I have to take the 5th root of 0.2984. So I'm going to type in on my keypad the number 5. Then I'm going to hit the math button. And I'm going to select 5. And it's going to give me something that looks like this. And I'm going to put in 0.2894. And when I do that, what do I get? 0.7803. And it asks me to round my value of B to the nearest hundredth. So we're going to say that B equals 0.78. So what is the equation that we can come up with that models this graph? Y equals what? Yeah, y equals 38 parenthesis 0.78, close your parenthesis, to the power of x. You guys did that. That's awesome. And that's not a nice one, right? That's a kind of a messy one. So the second part says, okay, how can you interpret the value B? Now, Hayden told us that it's decay. And so if I want to find the percent of decay, if I want to find the percent of decay, how am I going to do that? Well, how did decay happen? Remember that decay is 1 minus the rate. So I need to take 1 minus the 0.78 to figure out what the actual percentage is, right? So what's 1 minus 0.78? It's 0.22. And 0.22 as a decimal, when I multiply it by 100, turns into 22%. And that's what it's asking for. It's asking you for what is the decay percent, like what percentage is the depth of the water decreasing every day? What percentage? And it's the water is draining at a rate of 22% per day. The water is draining at a rate of 22% per day.